a second. Yeah, so I will start with the national anthem now. That is our protocol of our team, IDYM Foundation. And then later on, Denul will give you the welcome speech. And then yes, Sangvi will be giving you the idea how can you build your own satellite. Since he has worked for Pratham satellite, it was a dream of 8 years. He has worked like anything, and then finally it was launched from ISRO Center, Sriharikota, from rocket number PSLV C-35. India have got different rockets, so it was launched from one of the rocket, which was made by ISRO only. So it's a fully made Indian satellite, and it is made by a student of IIT Bombay. It's a great achievement because you all of you know that IIT Bombay is the #1 college also in India, and he has studied from there. He has been awarded by Prime Minister of India gold medal. So now I request all the students, please unmute your video, don't unmute your mic. और बेटा अभी हम नेशनल एंथम चालू करने जा रहे हैं, तो आप लोग उसके लिए तैयार हो जाएं, सभी लोग अपनी जगहों पर खड़े हो जाएं राष्ट्रीय गान के सम्मान में। और उसके बाद डेनुल आसमी जो तमिलनाडु से है वो आप लोग को वेलकम स्पीच देगी, और उसके बाद आपको यस सांघवी जी बताएंगे कि आप खुद की सैटेलाइट कैसे बना सकते हैं। सो यस डेनुल, प्लीज प्रोसीड विद द नेशनल एंथम।
जन गण मन अधिनायक जय हे भारत भाग्य विधाता, पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा, विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा, तव शुभ नामे जागे, तव शुभ आशीष मांगे, गाहे तव जय गाथा, जन गण मंगल दायक जय हे भारत भाग्य विधाता, जय हे जय हे जय हे
Yes, everyone, you can take your seat. And now I request Denul Asmi, brand ambassador of IDYM Foundation, a very energetic girl who is working from the beginning of the IDYM Foundation, day and night, helping all the way to reach up to this level, as we have completed 28 state of India. And I salute one of our Vice President, Yes Sanghvi ji. He is also continuously working for IDYM Foundation. That's how right now, after a few days, we are going to launch our workshop program in United Arab Emirates, and we are going to conduct more than 15 workshops in UAE. And after that, we are moving to Kuwait, then Saudi Arabia, then all around the world. Already we have completed the whole country. Now we are moving to other countries. Yes, Janur, please proceed with the welcome speech.
A very good afternoon, everyone. It's a pleasure to meet you, and I'm so happy to see you all together here. This is Denul Ashmi, brand ambassador of Igniting Dreams of Young Minds Foundation. It is my pleasure to welcome you all and thank you to each and every one of you for being here with us today. We are very pleased to be able to welcome those of you who have been with us today for the workshop, and we are really happy to host this workshop on a wonderful place, Uttar Pradesh, with you all. Once again, I warmly welcome you everyone. On behalf of Igniting Dreams of Young Minds Foundation, I would like to express my sincere thanks to all of you who generously helped us to make this event come together to become a success. We could not have done it without you. I warmly welcome our Honorable Chief Guest Deepak Sharma sir from IIT Kharagpur. I felt grateful to welcome Engineer Swapnil Talukdar sir from NASA and Engineer Yash Agvi sir from IIT Bombay. I heartily welcome APS International School, Uttar Pradesh. Also, I warmly welcome Ravishankar Kumar sir, founder of IDYM. I welcome our dear students who are set to make this event a remarkable one. And our Igniting Dreams of Young Minds Foundation main aim is to promote space and satellite education for every young mind, that is for the entire student community from any schools and colleges all around the world. Well, I hope workshop based on satellite technology will help you to improve your knowledge and skill So I request everyone to utilize the golden opportunities of IDYM. Take a shot and join with us on this fun-filled journey. With all enthusiasm, I welcome you all once again to the Momentous event. Today will be full of fun and learning. A big thank to each and every one of you present here for joining our program. Hope you will enjoy this workshop. Have a great day.
And I hope Deepak Sharma have also joined the meeting. And yeah, yes, Sangviji. So I request yes, Sangviji, please kindly proceed with the today program. यस बच्चों मैं आप लोगों को थोड़ी सी बात बताना चाहूंगा हिंदी में कि यस सांघवी जो वो इंसान है जिन्होंने 8 साल मेहनत की, ये भी नहीं सोचा कि इसके बाद क्या होगा, इन्होंने बस मेहनत की और उसका नतीजा ये हुआ कि भारत के PSLV C-35 रॉकेट से उनकी सैटेलाइट गई जिसका नाम प्रथम है। हर आदमी चाहता है कि मैं अपनी लाइफ में प्रथम हूं और इन्होंने एक मैसेज दिया पूरी दुनिया को कि आप भी अपनी लाइफ में प्रथम हो सकते हो। और इसीलिए भारत के माननीय प्रधानमंत्री मोदी जी ने, बहुत बड़ी बात होती है भारत के प्रधानमंत्री से मिलना, एक ड्रीम होता है, उन्हें IIT बॉम्बे में आके उन्हें सम्मानित किया। दैट्स अ रियली ग्रेट अचीवमेंट। नाउ आई वेलकम एस सांघवी जी, प्लीज टेक द चार्ज।
Thank you, Ravi ji. So let me start by sharing my screen.
हाँ बच्चों, अभी यस सांघवी जी आप लोग के साथ स्क्रीन शेयर कर रहे हैं जिसमें आपको बताएंगे किस तरह से उस पूरी सैटेलाइट बनी और क्या डिफिकल्टीज आप फेस कर सकते हो जब आप एक सैटेलाइट के बारे में सोचोगे। उन्होंने अपनी पढ़ाई IIT बॉम्बे से की है और आप सोच लो कि यस यू कैन सी ऑन द स्क्रीन, यस प्लीज।
Right. So thank you everyone for joining here. So in this workshop, we will be speaking about the journey of Pratham satellite and what all challenges we faced, how we overcame them, and what you can take away from it. So I will consider this meeting as successful if you after this meeting you have that confidence. Hello, am I audible?
Everyone please mute your mic, his voice is audible, I can hear his voice। तो बच्चों अगर आपको थोड़ी सी नेटवर्क की इशू है तो आप डिस्कनेक्ट होके कनेक्ट हो जाना। उनकी आवाज बिल्कुल साफ आ रही है जो कि मैं यहाँ पर सुन पा रहा हूँ। ही इज कनेक्टेड फ्रॉम मुंबई एंड आई एम समवेयर एल्स बट हिज वॉइस इज वेरी क्लियर। इफ यू आर फेसिंग प्रॉब्लम डिस्कनेक्ट योरसेल्फ एंड कम बैक। यस प्लीज यस सांघवी जी प्रोसीड।
Right. So yes. So I would consider this meeting successful if after this meeting you have the confidence that even you can build a satellite or do anything challenging for that matter. Building satellite is one thing, but you can do anything challenging which you right now feel that, oh, this is out of my reach, or this is something that is so difficult that I can't do. After this meeting, if you have that confidence, then this meeting is successful. Right. So before going into the details of the story of Pratham, let's generally speak about space first. So why do we do space research? Why do we build satellites? What is the point of all this? So a few days ago there was a cyclone that came in on the east coast of India. You must have read about it in the news, and a lot of people were evacuated. A lot of arrangements were done by the government to make sure no one loses their lives, and everyone was safe. There was hardly any damage caused by the cyclone to human lives. Property, obviously, the cyclone destroyed, but human lives were saved because we knew about the cyclone. Now, how did we come to know about the cyclone? See, these satellites that are sent, that are capturing images of the oceans, that are capturing weather patterns, they warned us beforehand that a cyclone is coming up. Right. Right now, some India-Australia test series is going on, and you are able to watch it live on your television, even though you are in India and the match is going on in Australia. Now, there is no cable directly connecting India to Australia, right? India to Australia, there's a big ocean in the middle, and there is no direct connectivity. So how are you getting the live broadcast? It is through satellites. In a lot of places where we conduct this workshop, people are able to participate in this workshop because the satellites are providing internet connectivity. So space and satellites, they have the capability of connecting people that is better than any other means of connecting people that we know so far. They have the capability of solving our problems, and they have a capability of warning us about the problems that are going to come, right? So in short, space research, satellite building, they help a great deal in improving lives of humans. That is the point of all this. Space can be used for the betterment of humanity, right? And the betterment, the benefit is one thing, but if you just look at space, if you just go out on a starry night and just look at the sky, you become very curious, right? So many billions of galaxies, each galaxy containing billions of stars, and each star having its own system. So just like we have our solar system, because the sun is the central star, each star will have its own system of planets around it. There are so many infinite possibilities. There are comets, there are asteroids, there are the moons of the different planets, and each of them has different atmospheres, different weather conditions, different geographies. And if you think about it, it's just so much exciting that you sitting over here in your home can explore this vast universe, can make new discoveries. A few days ago, some students from IIT Bombay, they discovered an asteroid which flew closest to the Earth, out of all the asteroids that have passed by Earth so far. And they were able to do this discovery sitting in their college campus. And they did this in a way that anyone else in this world could do this. So why did they do this? Because they were curious about space, because they were excited about asteroids, because they wanted to study various things, say black holes, etc. So, this quote summarizes it all. Space is a drawing book, and whatever kind of picture you want to paint, space will help you paint it, right? Uh, so, as a child, have you ever dreamt to roam around the world or touch the sky? So, most of us do, right? We have that plans that I want to go on a world tour, or I want to fly as high as I can, and so on. So I never did that, but my satellite Pratham has done that for me. Pratham satellite that we launched is moving around the Earth every 90 minutes. So it moves over India twice a day. Some morning around 10 a.m. it comes over India, and evening around 7 p.m. And you can also track the signals of the satellite when it is over you, and it moves through all parts of the world. It goes over all the countries. There is Brazil, there is Europe, Africa, US. It goes over every place, and everyone in the world can receive signals from Pratham. And it does so many times a day. Twice it comes over India, so you can see the speed at which it is moving. Right? It moves at 7 kilometers per second. Like if I were to go from Mumbai to Uttar Pradesh in 7 kilometers per second speed, I will be there in about 2-3 minutes. Right? Imagine Mumbai to Uttar Pradesh in 2 to 3 minutes. That is the speed with which the satellite is moving in space. And the satellite is obviously much higher than any aircraft can go. Most of the aircrafts are generally what, a few kilometers above the Earth. This satellite is 700 kilometers above the Earth's surface, and it has gone much beyond the sky. It's in space actually, right? So the satellite has been able to fulfill both of these dreams that we generally have as children, right? And which is the satellite that we are talking about? Pratham. So this is the image of the satellite. In fact, this is the image of the flight model of Pratham just before it was placed on the PSLV. So the Pratham satellite has to be weighed. Every satellite has to be weighed so that you can get an estimate of exactly how much mass it has. And even a difference of 100 grams would make a huge difference in cost, because the PSLV has to carry that much weight, and therefore it has to add so much fuel to carry that weight. So we had set 10 kgs, and this you can say 10.003 kgs. So just 3 grams more than 10 kgs. That's how accurate this satellite measurement has to be, right? And as it is mentioned here, Pratham is a journey of dreams. So how did Pratham start? So the person you see on the screen here, Saptarshi Bandyopadhyay, he and one of his friends, Sashank Tamaskar, this person on the left. So both of them were, attending a lecture or a workshop, just like you guys are attending this one. They were attending a workshop by TIFR, Tata Institute of Fundamental Research. It's a center in Mumbai. And over there, the professor was speaking about small satellites, their benefits, how to, how they help us, etc. And he and Sashank thought that why can't we make a satellite? Like, we are studying engineering. A lot of the concepts that the professor is talking about, they are related to what we are studying. So what is stopping us from making a satellite? Now, this question was a big shift in perspective. Generally, when people ask you, can you build a satellite? The question is, how can I make it? It is so difficult. It is, I am just a student. How can I make it? So many countries are there which haven't made a satellite, and I am a college student. But then this shift in perspective from how can I make it to why can't we make it? That made all the difference. That is the reason Pratham is in space today. Right? Because instead of how, he just asked why can't I? Right. And it's not to say that yeah, so in fact that's the statement that is highlighted here as well. Why not we? He asked this question in 2008, why not we? And in 2016, we were watching the live stream of Pratham satellite launch. All the members you are seeing here, they are all members of the Pratham team. All of them have contributed to making the satellite, and this is the reaction when the satellite was finally launched, right? So when he started the Pratham project, there was both a vision and a mission. What was the vision? The vision was not just to make a satellite and launch it. It was to convert IIT Bombay into a center of excellence in satellite technology. So what's the difference? You make just one satellite and launch it, okay, you know how to make a satellite. You become a center of excellence, it means that you understand satellite making, space exploration in depth. You are you can advise anyone who wants to make a satellite, you can guide them. That is the level to which they imagined IIT Bombay to be. And even that they saw the program is still continuing. There is a team within IIT Bombay after the launch of Pratham. They are working on several different projects. The rocket that launches satellite PSLV, the final stage of the rocket, which actually pushes the satellite in space, we call it stage 4, PSLV stage 4. So they are trying to make use of that stage also, because that stage is also moving in space, right? After launching the satellite, what is it doing? It is just moving in space. So they are trying to make use of that to send some signals to Earth, or make some measurements in space. Then they are working on missions to send some microchips to moon. So a lot of things are happening. Making satellite was just one of them. And he also had a mission. The mission was that we will not keep our knowledge within us. We will spread it out across India. Everyone in India should get an opportunity and the knowledge to make a satellite. This workshop that we are conducting is kind of on the lines of the mission that he had set out for the team, right? So uh, let's come to the actual building of the satellite. So a lot of people, when they think about satellite space science, they think about rocket science. It's a term that is used to show that a problem is not hard. Whenever you want to say that something is not hard, you say it is not rocket science, implying that rocket science is actually hard. But actually that's not the case. If you look at it from the outside perspective, it does seem very hard, but when you actually start doing it, you realize that it's almost like similar to other engineering problems that we solve. The only difference is that you need to have these three qualities. Your work should have a high degree of quality. It should be very precise. I told you about the weight example, right? We were told that the satellite should be 10 kgs, and we actually had to be very much in that bound. So we just had 10 kgs and 3 grams. That's how precise it was. Just a difference of 3 grams. And we had to be very professional. You know, when you make a satellite, you have to forget that chalta hai attitude, because space mein kuch nahi chalta. Even one thing goes wrong and your entire project failed. I'll give you an example of both, you know, quality and professionalism. So this is how the satellite's internal structure looks like. Once you open up one panel of the satellite, this is how it looks like from the inside. You can see so many pins within the satellite, so many connections. Out of all of these, we just had one connection which was not, you know, soldered properly, or which was not connected properly. So it was working well at room temperature. In normal conditions, it was working well. But whenever the temperature fell below 0 degrees Celsius, at that time the connection got broken and the satellite would stop transmitting signal. You imagine thousands of pins, out of which only one was not working, was not connected well. And because of that, our satellite mission was almost going to be postponed indefinitely. But luckily, you know, we figured out what was the problem, and we were able to solve it, and that's how the satellite got launched. But just one pin was almost going to sabotage our entire mission, right? So that is the amount of quality that you have to ensure. Not even a single pin should go wrong. The screws that we use for uh, uh, for attaching the panels, the PCBs to the boards, they should not have even a few millimeters gap between them, because then if they have that gap, it is possible in space they may come out loose, then they will hit other boards and then just destroy the satellite. So that's the kind of quality standards. And what about professionalism? So we discovered this when we were doing a test in ISRO. In fact, this is the photo of the test, the satellite just before it was going to be placed in that chamber. You see the chamber in the background? So we were just going to push the satellite in the chamber, and the satellite would stay there for about 40 hours. The chamber would be vacuumized, so all the air from the chamber would be removed. There is no air in space, right? Space has just vacuum. So just to simulate space environment, all the air in the chamber would be removed, and the temperature would be taken from a very high value to a very low value. Because when the satellite is directly facing the sun, the satellite's temperature would be very high. But when there is earth between the satellite and the sun, at that time the satellite's temperature would be very low. So we, to simulate the satellite's orbit when it's in front of sun, and when there is earth between the sun and the earth, we used to take the temperature from high value to low value, high value to low values. Thermal cycles these are called. And we used to test the satellite. So this is a 40-hour test, and 30 hours into this test, we discovered that this one pin has a problem. When the satellite temperature went below 0 degrees Celsius, during the low temperature range, we realized, okay, this pin is creating a problem, and the satellite is not transmitting signals. And even though 30 hours had passed, we were just given 1 hour to figure out what is the problem. Otherwise, they were just going to postpone our test indefinitely. And we had to do something, otherwise our satellite would may not even have been launched. So this is the kind of professional attitude that you need to develop. At that point, you couldn't have said, sir, positive mein to chal rahna chalta hai. That doesn't work in ISRO. It has to work in every condition. It has to work in all the harsh situations, right? So that's how much is how much of I would say professionalism is required. And nothing could be achieved without hard work, perseverance. So we built a satellite when we were students, right? So we used to have lectures in the morning, then we used to have some labs in the afternoon. In the evening, we would have some assignments, some extracurricular activities. Then at night, we would have dinner. Then we would come to the satellite lab at around 9 p.m., 10 p.m. Then till 3 a.m., 4 a.m., sometimes the entire night, we would just spend working on the satellite. The weekend, Saturday, Sunday, when we don't have lectures, that day, those days, full days, we used to spend working on the satellite. Because making a thing like satellite doesn't happen without hard work. You need to put in your 100%. Only then the satellite tests you in every possible way. You know, the Ratnesh Mishra, he is one of the ex project managers. He said that we always thought that we were building Pratham, but actually, through the entire journey, Pratham was building us. In other words, Pratham was testing us throughout. Pratham was building our character. Pratham was building our skills so that we could excel in satellite and space technology. Right. And I spoke to you about the technical challenges. But when you build a project like this, it comes with its own set of people challenges as well. So Saptarshi, I told you, he started the project with Sashank. Now, after Saptarshi, there were 7 project managers. You see, 8 years were taken for the satellite to launch. Ratnesh and Manvi finally got the satellite launched. And think about it, whatever dreams, vision, and mission that Saptarshi had, they had to pass it on till the seventh, eighth project manager till the satellite got launched, and even after that, because the project continues, right? So think of the challenges. You know, Tushar that you can see over here, when he was the project manager, the team was down to 3 people, and he had to take the decision whether to continue the project or close the project. And no one thought that the satellite would go ahead because there are just 3 people left now. At that point, he took that important decision that no, we will continue the project. He recruited people. He taught them everything, and then finally the people that he recruited, they were able to launch the satellite, right? So it's not just technical problems that you face, it's all kinds of problems. You face people problems, you face personal problems. People were not able to go home for years just because they were working on the satellite. One person from our team had booked tickets for going home after 1 year. 1 week before he was going to leave, he got some message that his help is required in the satellite team. So he either had to cancel his tickets and stay there, or he would go home and the team would not get his help. So he cancelled his tickets and postponed his home visit again for another 4 months. So this is the kind of dedication that people had put in for this project. And it was the result of all this that the satellite finally got launched. This is the rocket where, on which the satellite was placed, and right at the top, at the nose of this rocket, the satellite was placed, right? And after the satellite got launched, a lot of things happened. The prime minister tweeted about us, congratulated us. Our team was invited to China because they wanted to know how can students make a satellite. We were asked to present in a conference over there. The governor of Maharashtra, he's invited the team to his residence for felicitating us. Now, here's an interesting story. When we were going to the governor's residence, although in the picture you can see all the smiling faces, none of us were actually happy. The reason that on 26th September, Pratham was launched, and we were invited here on 28th. On 26th itself, we should have received the signal from Pratham, but that did not happen. 27th also we did not receive signal. 28th we were invited to the governor, but none of us wanted to go because the signal was not coming in. And so but anyway, we did go there. We just smiled for this picture, but none of us was actually happy. Then when we were returning from the governor's place, so this bus that you see, that is the bus of IIT Bombay. We were in this bus returning from his place, and we got a mail from London, University College London. They had received the first signal from Pratham. So they sent us the audio file. So the satellite doesn't talk to us in English, Marathi, Hindi, anything. It talks to us in Morse code, right? And the Morse code comes as an audio file. So they sent us an audio file, and generally a software is required for translating that audio to signal. Just like this, you can see the Morse code is at the bottom. This sound wave. The points at the top represent ones, and the bottom points represent zeros. So it's a 1010 pattern, and each character has its own pattern. For example, P would be 110, then R would be 101, and so on. Right. So a software listens to this and finds out what is the text. You can see it right here, right? It is decoding the message live. Pratham IIT Bombay student satellite. Right. But now we were in the bus, we did not have a laptop. How were we to find out whether it is actually Pratham signal? So the person from our communication subsystem, she actually just listened to this and she was able to tell, okay, this is from Pratham. That is the kind of expertise that she had developed. She did not even need any software for finding out this is a Pratham signal. She just listened to it and was able to find out, okay, I can see P, then R, then A. Oh, this is Pratham signal. Right. That is when we were actually happy. And that's how, the satellite making journey finally concluded. So, what was the point of this entire presentation? We just don't want you to, take away the message that you can build a satellite. We want you to take away the message that you can do anything difficult, not just making satellites. And there is so much more to space exploration than just satellite making. You can become astronauts. India is launching its own Gaganyaan mission. In 2022, some of the people from India will be going into space as astronauts. You can build your own space program. So, if you know about Elon Musk, he is in the news lately because he has just become the richest person on the earth. He made his own space program. You have heard of NASA and ISRO, right? These are government programs. NASA is by the US government, ISRO is by the Indian government. He made his own private space program called SpaceX. And SpaceX has launched so many rockets in space. It has launched even a car in space. You would have seen that news. And it has made reusable rockets. So most of the rockets that you see here, they can be used only once, and after that they are just destroyed. He made a reusable rocket that it goes into space, sends a satellite, then it comes back. So think about the amount of money that can be saved. you know every area of satellite and space exploration has so much potential for innovation. And there's so much more that you can do, and people are doing it. So Tushar that I spoke about, he has his own startup that is trying to make the fuel that is used for rockets. He's trying to make that more green or less pollution creating fuel, and he is trying to make it more efficient so that in less fuel you can have more power. Right. Then Saptarshi, who I told you about, he is working with NASA right now, and he's working on the project to make use of the craters of the moon as antennas. So you all have antennas on for your television, right? The dish type antennas. Now he said that okay, the craters on the moon, they are also like a dish. Why can't we use them as antennas for receiving signals from space? What an innovative idea, right? And he's actually working with NASA to create such a project. So there is a lot you can do. There is, making satellites is just one thing. And there is obviously space exploration. Just get a telescope and start looking at stars. You will discover so much. Just recently that Jupiter and Saturn great conjunction took place, which had a lot of media coverage. For the first time, Jupiter and Saturn were going to, appear together in space, and so many people were watching it using their telescopes. It happens once in 800 years, this event. So just exploring space itself is so amusing, so satisfying, right? So I think with this I can end my presentation. Just one final quote by Walt Disney: "If you can dream it, you can do it." He just built his entire Disney company with one mouse, Mickey Mouse, right? With just one Mickey Mouse, he has built his entire Disney company. Look how big it is so right now. You have Disneyland, you have so many animated movies coming out, you have so many action superhero movies, Marvel, Avengers, all of them are owned by Disney. All of that started with just one mouse. Right? So remember that. So
Okay,
Ravi,
yes,
I think, yeah.
yeah, yes, Sangviji, yes. I request the student to please ask some question in the message box. In the meantime, I request Deepak Sharma from IIT Kharagpur to address the student. Yes, Deepak Sharma, are you there? Hello, hello. No, he's not there. Okay, fine. Yeah, okay. So yeah, student, please ask some question. You can unmute yourself also, and you can ask the question. Any student, if you have any queries, आपको कोई क्वेश्चन पूछना है तो आप यस सांगवी जी से पूछिए. यहाँ पर जुड़े हुए हैं, वो आपके क्वेश्चंस का आंसर करेंगे। और मैं रिक्वेस्ट करूंगा प्रिंसिपल मैम अगर जुड़ी हुई मीटिंग में तो अनम्यूट करने के लिए और आज की मीटिंग के बारे में बताने के लिए।
Sir, may I?
या मैम, या प्लीज 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 आस्क प्लीज।
Sir, who is the founder of Pratham satellite?
जस्ट नाउ ही टोल्ड नो। यस जी, आपका माइक
Yeah,
बंद है थोड़ा सा।
I told in the presentation that Saptarshi Bandyopadhyay, I showed his image. He started the Pratham satellite.
क्या एनी अदर क्वेश्चन बच्चों? कोई दूसरा क्वेश्चन आपको पूछना है तो आप पूछ सकते हैं। हाँ,
Yes,
अभी
sir.
आप लोग
Can I, sir?
जो यस जी ने एक सेटेलाइट जो बनाई थी उसको लॉन्च करने की वीडियो है हमारे पास, मैं आप लोग को दिखाऊंगा कि किस तरह से वो लॉन्च हुई थी। यस, किसी को कुछ पूछना था मीन
Sir,
टाइम
can
में?
I?
Yes,
Yeah.
Naman.
Sir, yes, I am from class 12th. And
Yeah.
sir, my question is that I believe that knowledge is everywhere. We can collect that by ourselves. But the main challenging problem is that the cost of every part. I tried to make very things, but the satellite we can try to understand the every part. When we go there, we found that every single part is very costly, as in the movie Mangalyaan described that it spent 700 crores amount to make the full project. So how we can adjust that? If we try to work and even found something interesting, and if we go to work on that, then how can we adjust about the cost? I believe that we can gain the knowledge from YouTube and everywhere is knowledge, but the cost is the main problem.
Right. So I think your question is about how you can raise the money, right, for making satellite.
Yes, sir.
Right.
Absolutely, sir.
Right. So when let's take the Pratham's example. So when Saptarshi had the idea, he did not have the money. So Pratham took about 1 crore to build, right? And Saptarshi did not have that money to build Pratham, and no one else as students had that money. So how do you get funds? So Saptarshi approached the professor, and he discussed the idea with the professor. The professor said, okay, perhaps you just work for it on 6 months and show me if you can build something concrete and you can actually demonstrate something. Then we will discuss about funding. So Saptarshi went ahead, built a team, and they actually worked for 6 months just to demonstrate a proof of concept. For proof of concept, you just need to demonstrate it's working. You don't need the expensive parts. And when they finally did that, the funding was arranged by the institute. IIT Bombay got us some funds. Then ISRO also contributed some funds, and some funds were received from other companies like Boeing, for example. When you have a good idea, people do spend funds. The only thing is you have to first show that you are actually willing to work on it, and you can demonstrate some proof of concept so that the idea can be actually converted into reality. But once you have both of these, then people do bring out funds.
Yes, sir.
और कोई क्वेश्चन
Thank you
पूछना
very
है
much,
मीन
sir.
टाइम? या बेटा, अभी मैं आपको मीन टाइम में एक वीडियो दिखाता हूँ जो सैटेलाइट लॉन्च की वीडियो है, जिसको आप लोग देखो।
Remaining two satellites, Pratham from IIT Bombay and PISAT from PES University Bangalore are from India. The main objective of Pratham is to estimate the total electron count (TEC) with a resolution of 1 kilometer by 1 kilometer.
Have a feel of the launch.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, plus 1, 2, 3, 4,
and ground
5,
upon ignited.
6,
Vehicle
7,
lift off normal.
8, 9,
प्रक्षेपण जलन बिल्कुल सामान्य आकाश की ओर उठता हुआ PSLV और जोरदार
we will hear the confirmation of the separation of the Pratham satellite built by students of IIT Mumbai, and also followed just 10 seconds later the separation of PISAT satellite built by the students of PES University, Bangalore.
जी हाँ, वैसे कई उपग्रह इसरो भारतीय विश्वविद्यालयों के लिए छोड़ चुका है। जी हाँ, प्रथम उपग्रह भी अलग।
Pratham is separated.
कितनी जोश भर गई होगी जब प्रथम इज सेपरेटेड सुन के। तो बच्चों ये या इफ यू हैव सम मोर क्वेश्चन यू कैन आस्क हिम, ही इज देयर विथ अस राइट नाउ एंड या प्लीज शिवम गुप्ता यू वांट टू आस्क समथिंग। किसी को कोई पूछना है बच्चों तो पूछ लो, नहीं तो हम लोग अभी आने वाले 10 मिनट के अंदर मीटिंग बंद करने वाले। तो आपको अगर कोई क्वेश्चन है तो आप क्यूरीज है तो आप पूछ सकते हैं।
What is the एक chat में किसी ने पूछा, रणवीर सिंह ने, what is the main work of Pratham? Right. So Pratham was built to measure the total electron count in the ionosphere. So you have used GPS on your mobile phones, right? To for navigation, Google Maps, etc. Now you would have seen that there is some noise in GPS, and why that happens in the ionosphere. You know, above the atmosphere there is one layer called ionosphere. There are a lot of electrons in the ionosphere, and whenever the signals pass through these waves, they get a bit distorted. So Pratham was trying to estimate how many electrons are there in the ionosphere, so that we can correct the waves, correct the signals, we can predict how much they can get distorted, and that would give you more accurate GPS signals. So that was the whole concept, and in some cases, very rare cases, the same principle can also help us predict tsunamis. But that is anyway a very rare case, and you know, for that a tsunami has to happen by the time Pratham is in air. So that was anyway a secondary objective. Right.
बच्चों तो ठीक है, यस जी ने आपको काफी सारे इन्फॉर्मेशन दी। अगर कोई भी क्यूरीज है तो आप पोस्ट कीजिए, तब तक मैं मीन टाइम में आपको एक और वीडियो दिखाता हूं, क्योंकि यस जी की जो सैटेलाइट थी वो PSLV C-35 से लॉन्च हुई थी। और आपको ये भी क्यूरियोसिटी आपके माइंड में भी होगी कि PSLV वर्क कैसे करती है। तो ये छोटा सा एनिमेशन है, आप देखो। मीन टाइम में अगर कोई क्वेश्चन है तो मैसेज बॉक्स में डालो, और ठीक इसके बाद हम मीटिंग को क्लोज करेंगे। जैसे ही वो वीडियो खत्म होगा और एक दो क्वेश्चन के बाद हम क्लोज करेंगे।
India's PSLV C2 rocket is standing majestically on the launch pad at the Sriharikota range, ready to be launched. First stage and the four grounded strap-on boosters are ignited. PSLV is getting lifted off and clears the launch pad. Two air-lit strap-on boosters are ignited. The four grounded strap-on boosters are burnt out and are separated. Two air-lit strap-on boosters are separated. First stage is burnt out and separated. Second stage is ignited. Payload fairings are separated. The second stage is now burnt out and separated. Third stage is ignited. Third stage is burnt out and is separated. Fourth stage is ignited. Fourth stage is burnt out and the main satellite is separated. 3 microsatellites are separated.
देखा कि 3 माइक्रो सैटेलाइट्स आर सेपरेटेड, और इस तरह से सेपरेशन हो गया। तो अगर कोई आपको क्वेश्चन है तो पूछ सकते हो। शिवम गुप्ता, यस यू वांट टू आस्क समथिंग, एवरी टाइम यू आर म्यूटिंग एंड म्यूटिंग नॉट आस्किंग। कुछ पूछना है बेटा आपको, पूछो। यस नो प्रॉब्लम, ठीक है। यस जी, विथ योर परमिशन, या एनीबडी एल्स इज देयर हु वांट टू आस्क समथिंग? और प्रिंसिपल मैम, शी वांट टू स्पीक समथिंग। आई रिक्वेस्ट हर टू अनम्यूट, और एनी स्कूल कोऑर्डिनेटर राधिमा Tareja, ma'am, can you unmute yourself and say something about today's workshop? Yeah, ma'am, I think you are the school coordinator. I hope so. Yeah. So we can.
Yeah, sir.
Which part separate and third stage?
बेटा आप क्या बोल रहे हो? थोड़ा क्लियर बोलो बेटा। तनीश अग्रवाल।
I was right in the message box.
Okay,
which
आपने
parts
लिखा
are
है.
separated in the third stage. Okay. All right. So in all the three stages that are separated apart, there are some kind of fuel containers. So the first stage, you see all the boosters that are around the side of the PSLV, they are separated. Then first, second, and third stage, they contain different kinds of fuels for launching the satellite, and it is the fourth stage that finally contains the satellite. Right. So does that answer your question?
Yeah.
Thank
तो
you,
बेटा
sir.
आपको
सर
रवि भट्ट सर है क्या यहाँ पर? मिस्टर रवि भट्ट सर प्रिंसिपल हैं स्कूल के. आर यू देयर सर? आई थिंक इज नॉट देयर. ओके.
सर
How
तो
to
एक्सक्यूज मी
ठीक
सर.
become
है.
a space scientist? For becoming a space scientist, first of all, you need to uh, after your uh, after your 10th and 12th, you need to enroll in either a Bachelor of Science or a Bachelor of Technology or a Bachelor of Engineering. So either in the engineering or pure sciences field, you need to enroll, and you can do your masters in any of the fields: electrical, mechanical. You can even perhaps biology, because nowadays space biology is also taking a lot of momentum. Once you are done with your graduation, you can then either give ISRO's entrance exam if you want to specifically join ISRO. So they have their own dedicated entrance exam, or even after your 12th, you can join ISRO's own university. So they have a university, I think in Tamil Nadu, perhaps, where they specifically train you in satellite sciences. So that is one option. After 12th, you join ISRO's university, or after graduation, you apply for ISRO's entrance exam, and that is the way to join ISRO. And because in India right now, in space it's ISRO mostly. You can also, just like I told you about Tushar, who has his own startup in space field, you can also have your own startups after graduation. And other option is you can do a PhD in one of the satellite technology branches. So Saptarshi was the founder. After graduating, he went on and did a PhD in space robotics, and then he joined NASA. So there are several options. For starting off, just focus on uh, getting your science and maths right, and becoming curious. Curiosity is the most important thing for satellite and space technology.
Yeah, Radhima Tereja ma'am, can you unmute yourself?
Thank you, sir.
Radhima Tereja ma'am.
एक्सक्यूज मी
Radhima
सर.
Tereja ma'am, can you unmute yourself?
Yes.
Yeah,
Sir,
any
excuse me.
student who want to speak regarding today workshop, अगर आपको कुछ बोलना आज के वर्कशॉप के बारे में, तो you can ask, you can tell
Sir.
about today's sessions. Yeah.
On the behalf of Ridhima ma'am and our entire APS International School, I want to say that it is a very pleasure moment for all of us that you decided to set up such a great meeting and even a motivating meeting with us, and share such a wonderful and motivating views with all, to really igniting our mind with such a excitement. Thank you, sir.
Okay बेटा, thank you so much. काफी अच्छा लगा आपकी बातें सुन करके. तो मैं
Thank you
अब
very much, sir.
यस सांघवी जी से रिक्वेस्ट करूंगा कि अभी तो मुझे नहीं लगता बच्चों का कुछ क्वेश्चन है, तो मैंने नंबर दिया है और उस पर बता सकते हैं, आप पूछ सकते हो, और मैं यस सांघवी जी को पास करूंगा और वो आंसर करेंगे. यस सांघवी जी, विथ योर परमिशन, कैन आई क्लोज द मीटिंग?
Sure.
Yeah, I request before closing the meeting all the student unmute your mic. सभी बच्चे अनम्यूट करो और एक बार सभी एक साथ भारत माता की जय बोलो. सभी बच्चे का आवाज एक साथ आनी चाहिए. चलो बच्चों, 3, 2, 1 स्टार्ट.
भारत
ग्रेट बेटा, बहुत अच्छा लगा आप लोगों से बात करके हम लोगों को, और ऐसे ही हम आप लोगों के साथ जुड़े रहेंगे. और यस जी आपको हमेशा साथ देंगे. आप अगर कोई आइडिया लेके आओगे तो उसको जरूर वो बताएंगे, और आगे चल के आप खुद की सैटेलाइट जरूर बनाओगे. तो आज से ये मन में बना लो कि हमें एक सैटेलाइट बनानी है. सब मिलके, साथ मिलके ग्रुप बनाओ, नंबर दिया हो उस पर कांटेक्ट करो. और हमारे 4 सुपर साइंटिस्ट हैं, मानवी जी, यस जी, रत्नेश जी, वो सब मिलके आपको हेल्प करेंगे किस तरह से सैटेलाइट बनेगी. ठीक है बच्चों, थैंक यू एवरीवन.
थैंक यू वेरी मच सर.
ओके थैंक यू. एंड स्वप्निल जी भी हैं हमारे साथ नासा से, वो भी आपको हेल्प करेंगे. काफी सारे साइंटिस्ट हमारे पास, तो वो सभी लोग आपको मदद करेंगे। आप लोग एक आइडिया लेके आओ और उस पर काम करना चालू करो, फिर हम आपको हर तरह से मदद करेंगे। हम सभी एक मिशन के साथ काम कर रहे हैं कि जिससे हमारे देश के बच्चों का भला हो। आप सोच सकते हो कि आपके साथ IIT के साइंटिस्ट जुड़ रहे हैं, उन्हें काफी सारा काम रहता है, सभी लोगों को अपनी लाइफ में काम होता है, स्टिल हम लोग संडे को टाइम फाइंड आउट करके बच्चों को हेल्प कर रहे हैं। तो आप भी कुछ आइडिया लेके आओ और हमारे पास आओ, हम आपको आइडिया को इम्प्लीमेंट करेंगे और आप कुछ करोगे जो देश का नाम रोशन होगा। हम सभी देश के लिए जिंदा है, जी देश के लिए है। तो यस, थैंक यू एवरीवन, यू कैन ऑल लीव द मीटिंग बाय सेइंग जय हिंद जय भारत। इट इज माय